This is an exam question for anybody taking integral calculus in university first year. So I think if your professor is nice, then this is a partial fractions question that you could get on your final. So it's quite good, I would say. We did one that was easier last video. We're going to do some that are harder the next one. But it doesn't immediately scream partial fractions by looking at it. And actually, for me, when I look at it, I think, well, maybe there's a substitution here that I can get somehow. But if you look at it closer, you see that there's no real nice way to do it that way. So we tried partial fractions. So we have to split this up. The question is, how do we split something like this up with partial fractions? What is the actual statement? How do we introduce those constants of like A, B, and C? And the answer is this. When we go to set it up, and you can come check the website for the full explanation, but when we set it up, we have to look at the different terms. On the denominator, there's two different ones. There's x squared term, and then there's the x plus 1 term. For any of the squared terms, like let's do this one first. So it's x squared, right? We have to do an a and then a b on that same term. Because the x plus 1 is linear, that is, it's to the power 1, we just need one c term. But if this was also squared, then we would need c over x plus 1 plus d over x plus 1 squared. All right, that's the setup. This is the most important part, is being able to get this part. If you can get this far in partial fractions, then you're doing really good. Now what we have to do is we have to get a common denominator. So we multiply everything by this left denominator here, and things will cancel out. And we get an equation that looks like this. I'll save you some of the algebra just because we don't have time for everything here. It's not a full breakdown. And then we get this equation here. We can already start to solve for stuff. This is supposed to be true. This statement's true for all x, so we can start playing around with values. For example, x is equal to 0. That's going to cancel out this one entirely, this one entirely. This one, it's going to leave us right away with b is equal to 1. So that's great. We can try x equals negative 1. And then this one cancels out, this one cancels out. We got some algebra here and here to do, right? So you can already start to play with x values to solve for your a, b, and c values. You can also formally set it up and solve the algebra. Like this is the typical way that it's done, and it works totally great. You should know how to do that, absolutely. We solve for the coefficients. We get them here. Okay, great. So now we can rewrite that initial fraction that we had, that decomposition, with their values. So we had a is equal to 1, b is equal to 1, c is equal to negative 1. So there we go. If you're enjoying this sort of content, please leave me a like, leave me a subscribe. It does really help. If you want to see more, please do those things. That would be really great. So yeah, and then after that, we just integrate those terms. Now that we have those values, we just integrate and we get our answer there. So that's a great exam question. If you don't know, I'm Sheldon. I show you how to solve mock and modified past exam questions for your university courses. I hope this helps.